Proximity sensors are sensors that detect the movement or presence of an object without making physical contact with the object and converts that information captured into an electrical signal. Devices such as limit switches detect an object by physically contacting it, but proximity sensors detect the presence of an object without touching it. As these sensors are non-contact sensors, they do not cause any damage to the object. Proximity sensors do not use any type of physical moving parts. Instead, they allow signals to transmit through them when something that is being monitored comes in close proximity of the sensing area. There are many types of proximity sensors and they each sense the presence of an object in their own distinct ways. The two most commonly used proximity sensors are the capacitive proximity sensor and the inductive proximity sensor. Now let's discuss about capacitive proximity sensors. Working principle of capacitive proximity sensor. Capacitive proximity sensor is based on the principle of a parallel plate capacitor. Parallel plate capacitor consists of two parallel plates that are separated by a dielectric material which is a poor conductor of electricity such as plastic, glass or porcelain. The two parallel plates are conductive and they are usually made of aluminum, tantalum or other metals. A metal plate typically has an equal amount of positively and negatively charged particles, which means it is electrically neutral. If we connect a power source or a battery to the capacitor, a large number of electrons start moving from the negative terminal of the battery through the conductive wire. When these electrons reach the right side plate of the capacitor, the dielectric material will strongly oppose the movement of electrons from the right side plate to left side plate. As a result, number of electrons, that is the negative charge carriers on the right side plate of the capacitor, will be higher than the number of protons, that is the positive charge carriers. Due to this, the right side plate of the capacitor becomes negatively charged. At the same time, the electrons on the left side plate experience a strong attractive force from the positive terminal of the battery. As a result, the electrons leave from left side plate and will be attracted towards the positive terminal of the battery. Due to this, the number of protons will be higher than the number of electrons in the left side plate, and as a result, the left side plate of the capacitor becomes positively charged. This is how the charging of capacitor takes place. The right side plate has now developed a net negative charge and the left side plate has developed an equal net positive charge. This creates an electric field with an attractive force between them which holds the charge of the capacitor. The ability of a capacitor to store electric charge when a voltage is applied is called capacitance, and quantity measuring the ability of a dielectric material to store charge is called dielectric constant. The capacitance of a capacitor is directly proportional to the dielectric constant of the material between the two plates and inversely proportional to the distance between the two plates. There are two types of capacitive proximity sensors. The first one is dielectric type capacitive proximity sensor and the second one is conductive type capacitive proximity sensor. Dielectric type of capacitive proximity sensor. Dielectric type of capacitive proximity sensor can detect any target that has a dielectric constant greater than air. It has two parallel plates inside the sensing head which operates like an open capacitor. Here air acts as the dielectric. When no target is present, the capacitance between the plates will be very less. These plates are linked to an oscillator and a detector circuit. As a target which has dielectric constant more than air comes near to the sensor, the capacitance between the plates increases. Increase in capacitance increases the amplitude of the oscillation of the oscillator. When the oscillation exceeds a specific value, the detector turns on the output of the sensor. When the target object moves away from the sensor, the oscillation amplitude decreases, and when it falls below a threshold value, the sensor returns to the initial state. Dielectric type capacitive proximity sensors will sense both metallic and non-metallic objects. Conductive type of capacitive proximity sensor. In conductive type capacitive proximity sensor, there is only one capacitor plate inside the sensor. The target itself becomes the other plate of the parallel plate capacitor. The plates of a parallel plate capacitor should be conductive. So this type of sensor is used if the target is an electrically conductive material. The air gap between the sensor and the target functions as the dielectric. The plate inside the sensor is connected to an oscillator circuit that is used to generate an electrostatic field. As the conductive target approaches the sensor, the distance between the two plates decreases, due to which the capacitance increases and results in increase of oscillation amplitude. Once the oscillations exceeds a predetermined value, output signal from the sensor is generated, which indicates that the target has reached near the sensor. Now let's move on to inductive proximity sensor. Inductive proximity sensors are used to detect metal targets. An inductive proximity sensor has four main components. The first one is the coil. The coil generates necessary electromagnetic field. A cup-shaped magnetic core holds the coil. This core is necessary to concentrate the coil's magnetic field on the front area of the sensor. The second part is the oscillator. The oscillator is generally an LC oscillator. It produces radio frequency, which helps to generate an electromagnetic field. The third part is the trigger circuit. The trigger circuit senses the change in amplitude of oscillation and gives the signal to the output circuit. The last part is the output circuit. The output circuit has a transistor. After receiving the signal, the transistor switches on and gives an output. Working principle of inductive proximity sensor. Inductive proximity sensors operate on the basis of Faraday's law of inductance. According to Faraday's law of induction, when an electrically conducting object is placed in a time-varying magnetic field, an electric current called eddy current will be generated in the object. And according to the Lenz's law, the eddy current creates a magnetic field in a conductor, and this eddy current magnetic field opposes the magnetic field which created it. Now let's discuss the working of an inductive proximity sensor. The proximity sensor is installed in the area where we need to sense the presence of an electrically conductive target object. When the sensing coil in the oscillation circuit is supplied with an alternating current, a changing magnetic field is created around the coil. When the target object enters this electromagnetic field, some of the electromagnetic energy is transferred to the object. According to Faraday's law of induction, an electric current called eddy current will be generated in the object. This eddy current produces another magnetic field called eddy current magnetic field, and it opposes the magnetic field which created it. As the eddy current magnetic field opposes the magnetic field of the coil, the intensity of the magnetic field of the coil reduces. As the target comes very close to the sensor, the eddy current increases, decreasing the amplitude of the electromagnetic field. The trigger circuit monitors the amplitude, and when the amplitude goes below a predetermined level, the output state of the sensor switches from its normal condition. As the target moves away from the sensor, the amplitude of the electromagnetic field increases, and at a predetermined level, the trigger switches the output state of the sensor back to its normal condition.
Layar HP yang mati saat kita menelpon tidak hanya terjadi di Zenfone C, tapi semua smartphone zaman sekarang juga mengalaminya. Kenapa? Karena ada ini. Ini adalah sensor proxymity yang berfungsi untuk mendeteksi objek yang berada di depannya. Inti dari cara kerja sensor ini adalah memancarkan sinyal elektromagnetik dari satu lubang dan pantulannya diterima di lubang satunya, sehingga jaraknya bisa dihitung. Ketika kita sedang menelpon, sensor ini akan aktif dan mematikan layar HP-nya ketika sudah didekatkan ke telinga. Kenapa dimatikan? 1. Supaya isi dari HP kita tidak teracak-acak karena sentuhan dari telinga. Kedua, menghemat baterai. Dan yang ketiga, supaya telinga kita tidak panas. Jika kita harus tekan 1 untuk berbicara dengan customer service atau mau mencatat sesuatu, maka tinggal jauhkan HP dari telinga dan layar akan hidup kembali. Ini sih semuanya juga udah tahu. Sensor ini juga bisa kita temukan di mobil. Anda pasti pernah mendengar suara pip 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 ketika mobil sedang memarkir kan? Itu karena proximity sensor. Punya pertanyaan lain?
Nugroho. Pada video kali ini saya akan mencoba untuk menghubungkan atau membuat sistem alarm untuk keamanan di rumah kita dengan menggunakan alat dan bahan yang sederhana. Nah, yang pertama saya mempunyai sensor dengan jenis sensor PNP. Nah, sensor ini sensor proximity, induktif proximity yang mendeteksi adanya logam. Ketika sensor ini mendeteksi di depannya ada objek logam, maka kabel outputnya akan mengeluarkan sinyal positif 24 volt karena saya menggunakan power supply 24 volt untuk sensor ini. Kemudian yang kedua, saya memiliki buzzer DC dengan tegangan 3 hingga 24 volt. Kodenya SFM 27B. Ini kemudian di dalamnya tentu ada piezo, kemudian ada PCB juga kecil. Nah, bunyi dari buzzer ini adalah tidak menyala terus, namun seperti flip-flop. Jadi nyala mati, nyala mati, nyala mati, dan seterusnya. Kemudian buzzer ini memiliki spesifikasi atau tegangan DC untuk beroperasi. Nah, nanti untuk pengkabelannya, kabel hitam yang dari sensor ini nanti dihubungkan dengan kabel merah yang ada pada buzzer ini. Kemudian untuk kabel hitam nanti dihubungkan ke ground dari power supply. Oke, kita coba untuk menjajal sensornya terlebih dahulu, apakah sudah terhubung dengan baik. Ini adalah sensornya, kemudian di belakang ini ada lampu indikatornya. Saya akan mencoba untuk memberikan objek berupa induktif, bahan induktif ke depan sensornya. Nah, ini dia menyala, indikatornya menyala merah, berarti sudah terhubung dengan baik. Kemudian saya akan menghubungkan kabel merah ke output dari sensor. Kemudian kabel hijau mendapat ground dari power supply, saya hubungkan ke kabel hitam. Oke, sudah seperti ini. Kemudian kita tes. Kita akan tes seberapa kencang buzzer ini. Kencang sekali ya teman-teman ya. Bahkan buzzer ini tadi bergerak karena getarannya lumayan kencang, karena saya menggunakan tegangan 24 volt yang merupakan tegangan maksimal dari alat ini. Karena 3 hingga 24 volt saya menggunakan sensor 24 volt juga, maka suaranya paling kenceng ini. Jadi cocok untuk sistem keamanan. Misalnya ketika kita memasangnya di pintu atau di lokasi tertentu yang memungkinkan untuk mendeteksi adanya perubahan posisi pintu misalkan. Kita akan coba sekali lagi. Kencang sekali ya teman-teman ya. Nah, itu cara sederhana untuk membuat sistem alarm di rumah kita. Kita bisa bebas menggunakan sensor apapun ya. Kalau yang saya pakai di sini adalah sensor induktif proximity. Kita juga bisa menggunakan sensor inframerah tentunya, ataupun pasif infrared yang mendeteksi gerakan manusia, hewan, atau makhluk hidup yang mempunyai darah panas.
I just had to let you know you're
One is the loneliest number that you'll ever do. Two can be as bad as one. It's the loneliest number since the number one. One is the loneliest number that you'll ever do.